Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic solutions for class 12 CBSE and this will be the part 4 of the topic. Now see, today we have to see solubility of a gas in a liquid. Now see, we will find that the solubility of gases in liquids will be affected by both pressure and temperature. Because we will see that the solubility of the gases increase with increase in pressure. See, we know that many gases dissolve in water. Oxygen will dissolve to a small extent, and this dissolved oxygen only helps to sustain all the aquatic life. But hydrogen chloride HCl is highly soluble in water, and the solubility of the gases is greatly affected by pressure and temperature. The solubility of a gas will increase with the increase of pressure. Now see, in this diagram we see there is a this is the system for the solution of the gases in a solvent. Here we find that the lower portion that shows the solution and the upper part is the gaseous system. Here the pressure is P, temperature is T. Okay, the pressure taken is P and temperature is T. So this is a system in which lower part is the solution and the upper part is a gaseous system. Now this is in a state of dynamic equilibrium. Dynamic equilibrium means what? The rate of gaseous molecules which are entering the solution phase and leaving the solution phase is the same. Okay. The number of molecules which are entering the solution phase and which are leaving the solution phase both are same. Now if we increase the pressure over the solution, if we compress the gas, you see, with the help of a piston, here we are compressing the gas. We are increasing the pressure over the solution. So this will increase the number of gaseous molecules per unit volume. Okay, here you will see in this area per unit volume, because the volume has been decreased because we are increasing the pressure. So this will increase the number of gaseous molecules per unit volume in which area? Over the solution. Okay, so here you see the number of molecules per unit volume over the solution has increased. So the rate at which the gaseous molecules are striking the surface also will increase, because here per unit volume number of gaseous molecules has increased. So the rate at which the gaseous molecules will strike the solution surface to enter it also will increase. Okay, this increase in pressure will increase the solubility of the gas, and after that we will strike a new equilibrium. We will get a new equilibrium, because here you see the number of molecules per unit volume has increased. So more number of molecules will be able to strike the surface of the solution, that is solution surface, and they can also enter it. So when they enter the solution, we say that the solubility has increased. So this will increase the solubility. This is the reason why on applying pressure the solubility increases, because per unit volume number of gaseous molecules are increasing. When more molecules are there, more will strike the surface of the solution and thus enter it, and thus the solubility of the gas will also increase. So here we will get a new equilibrium. So if we increase the pressure, it increases the solubility of the gas and we will reach a new equilibrium after that. Now, based on this, we have a law known as Henry's law. Henry's law states that at a constant temperature, we have to keep the temperature constant. The solubility of a gas in a liquid is directly proportional to the partial pressure of the gas which is present above the surface of liquid or solution. Okay, so temperature being constant, just now we have seen in this activity, I have just shown you in this diagram. When we increase the pressure, the solubility has increased. The same thing we are stating with the help of a law. Henry's law states that at a constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas which is present above the surface of the liquid or the solution. Directly proportional means as the partial pressure of the gas is more, the solubility also should be more. So mathematically P is equal to Kh into X. Kh is Henry's law constant. P is partial pressure of the gas. X is mole fraction of the gas. Mole fraction of the gas in the solution. Means when we will increase the pressure, number of molecules of the gas inside the solution will also increase because the solubility has increased. So as we increase the pressure, when partial pressure will be more, X will also be more. Okay. So the solubility of the gas in the liquid is directly proportional to partial pressure of gas present above the surface of liquid or solution. So when partial pressure increases, X also increases. X is mole fraction of the gas in the solution. Why mole fraction of gas can increase? It will happen only when the solubility has increased. Means more number of molecules are able to enter the solution or the liquid. Higher the value of Kh, lower is the solubility, because from this you see Kh is equal to P by X. Kh equal to P by X. So when Kh is more, keeping P constant, if we keep this P constant, if we increase Kh, X, when you increase Kh, X will decrease. X means number of that is not number, mole fraction of gas in solution. When Kh increases, mole fraction of gas in solution decreases, means solubility decreases. So higher the value of Kh at a given pressure, lower is the solubility of the gas in the liquid. So we can sum up that mole fraction of a gas in the solution is proportional to the partial pressure of the gas over the solution. Next we have to see effect of temperature. Now solubility of gases in the liquids will decrease with rise in temperature. As we increase the temperature, solubility will decrease. This happens because dissolution is an exothermic process. So it is exothermic process, heat is given out, and here if we will increase the temperature, solubility will decrease. Dissolution is exothermic. So here also it follows the Le Chatelier's principle. Since the dissolution is an exothermic process, the solubility will decrease with increase of temperature. Now based on this, let us solve one example, one numerical. If nitrogen gas is bubbled through water at 293 K, how many millimoles of nitrogen gas would dissolve in 1 liter of water? Assume that nitrogen exerts a partial pressure of 0.987 bar. Henry's law constant for nitrogen at 293 K is given as 76.48 K bar. Okay, Kh per K bar, it is always like that. That is kilobar. So we have to multiply into by 10 to the power 3 to convert it into bar. So it's kilobar. Now see, we know that solubility of the gas is related to mole fraction in the aqueous solution. In the solution, so mole fraction can be calculated as, first you have to find the mole fraction X for nitrogen. That is equal to the pressure, okay, partial pressure divided by Kh. This partial pressure we have to take for nitrogen only, and that value is given as 0.987 bar divided by Kh value 76.480. It is K bar, so we multiply by 10 to the power 3 to convert it into bar. When we solve it, we get it as 1.29 into 10 to the power minus 2, that is for this value 0.987 by 76.480. This 10 to the power 3, when it goes to the numerator it becomes 10 to the power minus 3. So overall it is 1.29 into 10 to the power minus 5. 1.29 into 10 to the power minus 5. Now 1 liter of water has 55.5 mole. Okay. Number of moles in 1 liter of water is 55.5 moles. So if N is number of moles of nitrogen in solution, then the mole fraction for nitrogen will be equal to X is equal to N by N plus 55.5, because we have to take the number of moles of water, it is dissolved in water. N is very less compared to that of the number of moles of water, so we can just it can be neglected. So it becomes X by 55.5. This is N. X is equal to N by 55.5. And this value will be equal to what we got just now, 1.29 into 10 to the power minus 5. Okay. Here why we are taking it as 55.5, because N is very much less than 55.5, so it can be neglected. N in the denominator is neglected. On calculation, we find that N equal to 7.16 into 10 to the power minus 4 moles. If you convert it into millimoles, what we do? Millimoles. Multiply by 10 to the power 3. So this will be 7.16 into 10 to the power minus 4 into 10 to the power 3 millimoles. Okay, so on multiplying, what we get? It will become 0.716 0.716 millimoles. So I hope students you all could understand the topic which I discussed today. Thanks for watching my video. Please subscribe to the channel. Thanks for watching. Thank you.